Hey everyone, this is Deepak Anand from Team Soup Devs. Our project is Instruere, Mine and AI Revolution. Our project problem statement is that processing power, that is GPUs, are often inaccessible to machine learning engineers in today's AI landscape. Available means and resources are quite expensive for AI development. Deep-in solutions for training their AI model are often complex. Developers often struggle to figure out deployment constraints. Our vision is to create a decentralized blockchain protocol that harnesses the collective computational power of users' devices for training AI models while offering rewarding experiences for all participants. Our solution is to design a novel protocol which trains an AI model as a proof of work while mining. Our approach distributes the training load on devices' specification based on their specification, enabling effective contribution and optimizing overall performance. We have built a simple extension which allows regular people to mine array token on Tron from their GPU-enabled laptops and TPU-enabled smartphones. We have also created a one-click deployment interface that allows developer to deploy training scripts effortlessly. Let's discuss TPU-enabled devices. As the name suggests, TPU stands for Tensor Processing Unit. Unlike GPUs and CPUs, they are often much more faster and efficient at handling AI workloads. CPUs like printing out letters, whereas GPU print out entire sentences, but TPUs are printing entire pages. TPUs are often used in smartphones to handle the AI workloads like image recognition, voice processing, and natural language understanding. TPUs are often underutilized in smartphones, but big tech companies like Google and Apple are increasingly embedding TPUs in their flagship smartphones. For example, Google Pixel. We have utilized federating machine learning approach, which distribute the AI training load across miners based on their device specifications. TP-enabled smartphones train for a limited time to avoid overloading, storing training checkpoints, CKPT as you can see in the picture. Multiple CKPTs are stored, which are created to handle AI training defaults. We pass them to other miners to continue their training. We ensure fair and efficient load distribution across devices. All miners, regardless of their capability, contribute to training. We rotate tasks, improves resource uses and training efficiency. You can see the user workflow here. An AI engineer uploads his Python script, which needs to be trained on the Instruere blockchain using the deployment interface. A miner comes over the Instruere blockchain to mine. On pressing upon the mine button, you are using the simple UI extension. The miner mines the Python script, which runs in background and trains an AI model. The model gets trained and deployed on the IPFS and Hugging Face, and nodes can verify proof of work using custom Hugging Face API that we have developed. Which is after verification, a block is added and an array token is awarded to the miner. Let's discuss technical architecture. We have a deployment interface where AI engineer uploads a Python script directly through the deployment interface on the blockchain. Python script and checkpoints are securely stored on the IPFS for decentralized access. On the client side, miner initiates the mining process by fetching Python script from IPFS upon pressing the mine button. Local execution, the scripts are executed locally utilizing miners' devices, resources for AI model point tuning. In federated machine learning approach is utilized. A federated machine learning approach allows TP-enabled smartphones to distribute training tasks effectively. Checkpoints are often saved on IPFS and can be loaded by other miners for continuous training. In the model verification and block addition phase, after training the fine-tuned model, AI model gets pushed on Hugging Face with repository ID predefined by the AI engineer. Verification. Nodes can verify contribution using Hugging Face custom API that we have developed before triggering the block addition through smart contracts. Reward distribution. In the reward distribution phase, a smart contract initiates reward distribution based on minus contribution to fine-tuning process. Rewards are allocated dynamically, reflecting participation and resource contributions. Market opportunity. AI market growth. Global AI market is projected to reach $733.7 billion by 2027, quoted by Statista. Federated learning, crucial for privacy preserving AI training, Kairos et al. At 2021. Smartphone penetration, 3.8 billion users globally, many with TP-enabled devices, quoted by Statista. Sustainability, utilizing existing devices for AI training supports environmental goals, quoted by Natural Communications. Competitive landscape, tech giants like AI and Google are integrating TPUs into devices, pushing smartphones' AI capability, which is quoted by NASCOM. Tokenomics. So we have created tokenomics for our project. Total supply will be 1 million array tokens, 40% of array for the miners who contribute to computing power for AI model training, 20% for reward for developer who deploy model on the network. 30% array token will be reserved for partnership, community growth, and initiative developer and grants. 10% array token will be rewarded to users who stake their tokens on and participate in governance decisions. 10% array token will be held in reserve to ensure long-term sustainability. 5% array token will be rewarded to team members for building and maintaining the platform. Onboarding initial users. We have initiated sessions at our university to onboard initial users. We educate newcomers and freshers about Web3 and blockchain technologies. Our project serves as a case study to illustrate the component of AI in Web3. Participants gain hand-on experience by engaging directly with our project. Roadmap. For phase one, we will be developing a prototype. In the first quarter, we will build the decentralized AI training framework with TPU and GPU integration and smart contracts. For phase two, beta testing, 3 to 6 months, onboard users, conduct beta tests, and refine features based on feedback. For phase three, we will do a public launch the full platform, integrate cross-chain functionality, and establish partnership. For phase four, we will be scaling and the ecosystem growth, expand our user base, support more AI models, and grow the ecosystem with new features. Our team. Our team consists of 3 members, Afzal, Sahil, and myself. Afzal is our backend developer. He has won two Web3 hackathons and he has an year of experience in Web3. Sahil and myself, both we have an year of experience in Web3. Sahil has cracked one hackathon. On the other hand, I have cracked 5 more hackathons. Thank you.